This is our flowgorithm for Project 17, counting the button presses. We have our integer I to do it 1,000 times. We have our an integer for how many times the button's being pressed, the target number that we want the computer to reach, and we start off at 0, and the amount of times the button's pressed is 0. We have this for loop for when it goes 1,000 times. The computer will choose a random number. We'll choose a random number between 1 and 10, and then once it equals 9, meaning it has like a 1 in 10 chance, if the amount of times the button's been pressed is less than 5, if that's true, we'll add 1 to the amount of times that the button's pressed, and then once it equals 5, or when it isn't less than 5, we will turn the button press will be equal to 1, and then once the button press equals 5, so once the button's been pressed 5 times, the output will be the light is on for 2 seconds, and then it'll keep doing that until it reaches 1,000 times. So if you play it, you can see the I went 1,000 times, the number to be pressed was 5, and the button press had to be 5 times, and then the target number was 9. So if it goes 1,000 times, and it has to be pressed 5 times, there should be like 20 light on for 2 seconds, which they approximately are. And we have our flow chart.
We have our flow chart here. You can see that it starts. Loops there, and it goes back to reading continuous anti-tackle. We have our code.
We have our tactile, previous tactile, our counter, and then our input, output, and our serial number. And then same thing, if it's true and the previous tactile is false, like the last project, if that is the remainder of it divided by 5 equals 0, we'll do the digital write 5 equals high, and then you wait 5 seconds, and then it will turn the digital write, it would turn off after then, and then our serial counter and our delay, and then our last one is our previous tactile equals our tactile. So we put it onto our board. 1, 2, 3, 4, 5, 2 seconds. 1, 2, 3, 4, 5, 2 seconds.